Okay, I'm just going to explain quickly experiment 13 as well as experiment 12, like the instructions of what you need to do and what to look for. So experiment 13 is going to be the first experiment, which was for last week, and then experiment 12 is going to be for this week, just in terms of the time period. So the first experiment was actually something that I was going to be demonstrating anyways. You guys actually weren't going to be doing an experiment, but the concept of the experiment was going to be about electrolytes. And so we know that electrolytes are ions that like dissociate in water, right? So when you have like an aqueous solution, you have these ions that dissociate, and they are considered electrolytes. And depending on how much that they dissociate, will tell you how strong or weak, or if it's an electrolyte at all, right? So if it like strongly dissociates, it dissociates completely, like NaCl, that'll be a strong electrolyte. If it partially different, somewhat separates, right, that'll be like a weak electrolyte. And if it doesn't separate at all, that will be a non-electrolyte, because there are no ions that are dissociated, and therefore there are no electrolytes. So the experiment that you will be looking at are just small videos of different solutions, and that will contain either a strong electrolyte, weak electrolyte, or non-electrolyte. So she will be in this in the videos. She will be going through procedure A. So you're just doing for 13, you're just going to be going over part A. So just this form here. Okay, so you're just going to be filling out kind of exactly the way I did with the marks, right, with the X's. You're just going to be filling out this page, and that's all that you need to take a picture of and upload is this page. And what all you need to do is indicate whether it's a non-electrolyte, strong electrolyte, or weak electrolyte. Okay, so for instance, a weak electrolyte is going to be displayed as a like dim light bulb. So the procedure will be her setting. It'll be this apparatus, and at the bottom here is where she's going to be dipping these rods into different solutions. Those 12 solutions are all that whole page of solutions, and each one of the solutions will show a strong, weak, or non-electrolyte. If it's a strong electrolyte, this light bulb will completely turn on. If it's a weak one, then it'll be kind of dim. It'll be a little bit like little flicker, but not as bright as like a really strong light bulb. And then the non-electrolyte, there'll be nothing that happens. Okay, so that's basically all you're looking for when you're looking at each one of these videos. You're trying to see, does the solution, the aqueous solution that she used, turn on this light bulb, like strongly, right? Because that's about conducting electricity. So does it strongly conduct electricity? Does it slightly conduct electricity? Or does it not conduct electricity at all? Okay, and so that's basically wherever you feel that that solution ends, right? So if you feel like, okay, this first one is distilled water, so that one I have is like a non-electrolyte. So that means like there was no light that came on. Okay, so that's what you want to do for experiment 13. And then for experiment 12 is the single displacement reaction. So in this experiment, what we were going to be doing was looking at kind of the reactant, the activity series. So if you guys remember the activity series, right, is that chart that's it's on the PowerPoint under activity series, and it has an increasing order of reactivity of elements, right? And so remember that when we have a single displacement reaction like this, right, we're going to look at each part and say, okay, well, we're going to look at A, and then you're going to look at the other cation, and you're going to see which one is more reactive, right, based on that scale. And then if the A is more reactive than the B, then there will be a reaction, right, because C always wants to be with the more reactive. So if A is more reactive than B, then A will switch with B, and C will be with A, right? So then you have B plus AC. But if it's not more reactive, so if B is more reactive than A, then there will be no reaction that takes place, right? Because it wants to be with the more reactive substance. So the concept of the single displacement is to show the experiment, or have experiments that kind of show this procedure. So the actual procedure is, as you can see, is actually really short, right? And so basically what she's doing is going to be each one of these pictures and videos is going to be going through this procedure. And so in the procedure, she has 6 different test tubes and several different strips of metal, so copper, lead, and zinc. So each one of those are like strips of metal, so that will be placed into a solution of some sort. And then just try to, like I said, maximize the videos, right, so that you can really kind of see what's going on. But what you want to see is is there a reaction that took place? For instance, is there gas that evolved, right? Do you see little bubbles? There might sometimes be like a deposit of some sort of color or a film on top of these strips, right? So sometimes you might see like this little kind of coating on one of the strips, and let's describe what that coating is, or just say if there's like a coating, then you could just say they're deposits, okay? And then you can also as well mention if there's like a color change or something like that, or there's no reaction. So that's kind of what you're going to put in the first part. And then for this experiment, you're going to do basically this entire page. So page 107 and 108, you will upload that whole page as well. So the experiment, which basically the whole point of the videos is to fill out this, the top portion of the single displacement reactions page on page 107. So that top portion is going to be what you fill out and through the videos. And then everything else is what you do on your own at home. Okay, so I'm going to go ahead and put on Canvas, I'm going to go ahead and put assignments up for the lab so that you can have places to upload those as well. All right, okay. All right, so hopefully you guys watch this and let me know if you have any questions or there's any confusion that you have on filling out these forms. But each one should have a form, just like, right, for lab before, you'd have to turn in your lab sheet. So every week going forward, you're going to have to turn in these lab sheets. So I'm going to have this due by Tuesday. Let's just say Tuesday. Okay, I'm going to put the date and whatnot. So we're going to turn this in on Tuesday. And I'm supposed to they just emailed me saying they're going to be uploading some more information for next week's lab tomorrow. So I should be able to get that to you guys hopefully tomorrow, or sometime next week, right? So like Tuesday and then Thursday. You'll turn it in on Thursday. And that going forward, it'll always be that you turn it in on Thursdays. But right now, since we're a little behind, just turn 12 and 13 in on Thursday. And just remember, chapter 8 is not due, but I put that up online. Chapter 7 is due today. So hopefully you guys turn that in. Okay, let me know if you have any questions. Bye.